So, topic, our second lecture for today is antiderivative. And you know, operations in mathematics, they have inverses. Inverses, I mean, for example, addition and subtraction, multiplication and division, and so on. And antiderivative, it's inverse of derivative. So to understand what is antiderivative, first of all, you should know very well what is the derivative. And that's why let's recall what is derivative, and I will now share my phone. Just a minute. I stopped this sharing and you see now my phone, and okay, we have whiteboard. So let's recall what is the derivative. And okay. Now, Raymond, be very careful.
Yes, sir.
And okay, so for derivative, we have very important formula.
Yes, sir.
It's x to power 9, derivative of x to power 9, it's n times x to power n minus 1.
Is equal to n raised to
yes,
power.
Yes. And what it means? It means that, for example, what is derivative, what do you think? What is derivative of x to x squared?
Correct.
Raymond, what is derivative of x squared?
Derivative of x squared is 2x.
Oh, yes, very well, very good, absolutely. It's 2x. Okay, yeah. Very good. Okay. For example, if we have 5 times x squared.
Yes, sir.
What is derivative? 5 times x squared.
5 times x squared.
Yes.
Is equal to 5 times 2x.
Absolutely, you are absolutely right. 5 times 2x, and yes. It's going to be 10x. Very good.
Yes, sir. Yes, sir.
Very good.
Okay.
5. My next question, and what we should know very well, it's what is derivative of 7?
The derivative of 7.
It's 0.
0.
Because yes, 7, it's constant number, 7.
Yeah. And it doesn't
7
have...
it's constant number, and derivative for any constant number is 0.
0, yeah.
Okay. My next question is, what is derivative of x?
Is 0.
No. Because x it's not a constant number.
It's x.
What?
X.
No. Derivative of x, it's 1.
Oh, really?
Yes. Derivative of x, it's 1.
Okay.
What about if we have 5 times x? What is the derivative in this case?
5 times x. Okay, that is 5.
In this case, we can 5 move
Yeah,
out,
5.
move out across derivative sign, across parentheses. We can move out 5, and we have 5 times derivative of x. But we know very well derivative of x, it's
This
0, and
Okay.
that's why, yes. And that's why derivative of 5x is 5.
Yes, sir.
Okay. Now
So-
let's answer your question. Our previous example was like this. X cubed
Yes, sir.
plus 3x squared.
Okay. So
Derivative.
x cube plus 3.
In this case, we have to use formula
Yep.
that
That is
some derivative of sum of function is sum of derivatives. So in this case, we have x cubed derivative x cubed derivative
yes.
plus 3 times x squared derivative.
Yes, sir.
It's going to be derivative of x cubed, it's 3 times x squared,
Yes, sir.
and derivative of 3x squared, it's 6 times
Yeah, 6 times
x.
x. Yes, sir.
Very good.
Yes, sir.
Everything is okay. Very good. Very good.
I got it right, sir.
Now, one more important formula, e to power x, derivative of e to power x.
Yeah.
And here, note, don't confuse.
Yes,
E
sir.
to power x,
Yes, sir.
it's different, absolutely different.
Is equal to
They are absolutely different.
yeah.
So derivative of e to power x, it's the same. Again, e to power x.
Yes, sir. Yes, sir. So okay.
Okay.
Okay, sir.
Now, as for antiderivative.
Yes, sir.
Antiderivative of function
Olashun
fx, antiderivative of this function
Yes,
is
sir.
function fx
Yes, sir.
such that derivative of fx it equals fx.
Okay. Okay.
Example. For example, fx equals x squared. My question is, what is antiderivative of this function?
Yes, sir.
Let's denote it by capital letter fx.
Okay.
Any idea?
The derivative of x squared.
No. It's given fx lowercase f x equals x squared.
Okay.
And we need to find antiderivative.
Okay.
Capital letter F. And what is antiderivative? Antiderivative is function such that derivative of this function is function
Itself.
f lowercase x. So we need to find function such that derivative of this function
Yes, sir.
should be x squared. Any idea what is this function?
X.
What?
X.
Let's try x.
Yeah.
Let's try x. And let's find derivative of x. What is derivative of x?
It's X.
No, 1.
Oh, okay. 1. Yes.
Sorry.
Derivative of x is 1. So
Yes,
your answer is not correct. Because we need such function such
Yes, sir.
that derivative of this function to be x squared.
Yes, sir.
Okay, Luca, what is your idea?
I have an answer that the derivative of x in x in power 3 by 3.
You mean x to power 3 divided by 3?
Yes.
Let's try, Luca. So Luca's hypothesis is that it's x cubed over 3. I write your...
No, this is not correct.
Okay.
Okay.
Okay, I will correct it. It's not correct. And what is your idea? I will write here. Sandro, do you have any idea? So we need such function. If we will take derivative from this function, I should get x squared.
My answer is yes. I have an answer that x to power 3 divided because in the denominator x in 3 is derivative of derivative.
So your answer is x to power 3 divided by what?
3x.
6?
3x. Sami.
3x.
3x?
Yes.
Yeah.
Yes.
But we can reduce it. So I get your answer is x squared divided by 3.
Yes.
But it is the same as x squared divided by 3.
Yeah.
X squared divided by...
No.
By
Derivative
2?
of x cube. Derivative of x cube is 3x.
What, Sandro? X squared divided by 2? Let's try, Sandro.
It should be x squared divided by 2.
Raymond, let's first check Sandro's hypothesis. X squared divided by 2. Let's find this derivative.
Yes, sir.
We have here constant.
Derivative of 2 is 0.
No. I can rewrite it. Look, I can rewrite it, Luca. 1 over 2 multiplied by x squared. Do you agree?
Yes.
Derivative. It equals 1 over 2 multiplied by 2 multiplied by x.
Yes.
This is shortest way to find this derivative. Of course, we can use quotient rule of derivative. Quotient rule. Do you remember? F divided by g derivative. But this is shortest way to move out 1 over 2 and find derivative. So it's x. Unfortunately, it is not x squared. We need to get after differentiation. In differentiation, it means to find derivative. after differentiation, we need to get x square.
Yeah.
This one.
Yes, sir.
Luca, why did you deny x cube over 3? Did you check it?
No.
No? Let's check.
I will check.
Let's check
Um,
your rejected idea. Let's check x cube divided by 3. Let's find derivative. We will follow the same way. Let's move out 1 over 3.
It's correct answer.
Let's move out 1 over 3. And we have x cube derivative.
Derivative.
And it's going to be 1 over 3 times 3 multiplied by x squared. So it's x squared.
Not correct.
Why not?
Raymond, it's correct because what we need function such that derivative of this function must be x squared, this function.
Okay.
And we got it. So now we know that
So, sir,
antiderivative of x squared, So if we have function fx equals x squared, antiderivative of this function, let's denote it by capital F, it's x cubed over 3. So,
Sandro is not correct.
No.
do you agree? I think you will agree because we have just proved it. Okay. Now my next question is x cubed over 3. Is it only function such that derivative of this function is x squared, or maybe exists other function such that derivative of this function will be x squared? What do you think? So we know one function definitely. This function, we know that derivative of this function is x squared. But now my question is, can we find different function such that derivative of this function also will be x squared?
Can make it as 2x.
Sandro, what do you think? Raymond, what do you think?
I don't think I have ideas.
Sorry,
I've tried to work it out, but I didn't get it. So I don't have any idea. Hello, sir.
Just a minute.
Okay.
Something.
Sandro, do you have any idea?
No.
Luca?
Not yet.
Ola?
Hmm?
So, do you have any idea?
2x.
What do you think?
2x over 2.
2x raised power 2.
What's the power 2? What about that?
What about function x cubed over 3 plus 5.
X
What do you think? What is derivative of this function?
Is
Derivative of this function.
over 3
derivative of any
5.
number is 0,
Ah,
so we
yes.
can use
Yes, derivative of any constant number is 0.
So it's the
So
same
if
thing.
we will differentiate this function, we will got the same answer x
It's the
squared.
same answer as x squared.
X squared.
Yeah.
Moreover, any function x cubed over 3 plus c will be antiderivative of function
Yes, sir. It
fx
will be x squared plus
equals
2.
x squared. Do you agree?
Yes.
Very good. Now, let's I will share now screen.
Hey guys, do we agree?
Just a minute.
Luca, do you agree with that?
Yes.
That x cubed over 3 plus c is equal to x squared.
I could not hear you clearly.
So this is definition of antiderivative.
Luca, don't use earpiece. You don't need earpiece. Your computer is it not working?
No, it's not a problem caused by earphones. It has the same quality of PC and my
Okay,
speakers.
maybe because of your PC then.
No.
Let me continue. Guys, let me continue.
Okay.
Yes, sir.
So, what is your answer for first function? Find all functions that have a derivative of 3x squared.
Function. Find all functions that have derivative. It's x in cube.
X cube,
X to
absolutely.
power 3. Yes.
X cube.
Or x
And
cube plus
let's see answer.
plus
X
constant,
cube
yes.
plus c.
Yes.
C because c is constant. And x cube plus c also is antiderivative. In the second case, what is your answer?
ex e to power
X plus
What, Sandro?
e to power x plus c.
Let's check.
Oh.
Yes, it's correct.
Yes.
How do we get x cubed?
Now, if we have a function
Well, I get it.
fx equals to x,
Hello, sorry, sir. Franklin asked one question now. What question do you ask?
How do we get that x cubed?
just a minute.
Yeah. Yes,
Yeah.
sir. 3x cubed.
Okay, we can check it, Raymond. We can check it. Find derivative of this function x cubed plus c. What will be derivative for this function? Derivative of c is 0 because it's constant.
Yes, sir.
You know very well derivative of x cubed is 3 times x squared.
Oh, okay. Oh, okay. Noted. So, all I'll get that.
Now, you can see now two functions and both of them are antiderivatives of function 2x. And graph of these functions are vertical transmission for each other. Do you remember vertical transmission or shifting? We can say shifting, vertical shifting.
Yes.
Now you see now definition of indefinite integral. Indefinite integral, it's family of all functions that are antiderivatives of function fx. Look very careful. Ask if you have question. If you have no question, I have one question.
Maybe I don't have a question.
What is your question, Luca?
I don't have question.
Okay, very good. My question is, what is the difference between antiderivative and indefinite integral?
I have an answer. That antiderivative is one function
Yes,
which derivative
absolutely
is
right. Absolutely. Absolutely.
Yes.
Great, Luca. Antiderivative is only one function. But indefinite integral, it's set of
All of
functions,
functions.
family of functions.
Mhm.
Okay, very good answer. Okay, now let's solve it. But to solve it, we have some formulas for indefinite integrals.
Could I take a screenshot?
Sure, sure. So, first formula, it's obvious, but take in account that it's true for any n. It does not matter. It's natural, it's integer. It's true for any n.
Mhm.
But n should not be equal -1.
Mhm.
Because when n equals -1, here we have
No, 0.
n -1 is 0 and we can divide by 0. So this formula does not work for n equals -1. I think second formula, it's obvious because you know very well that derivative of e to power x is again e to power x. So, of course, integral of e to power x is again e to power x. Now, for example, here in the first formula, we have n equals -1. What happens? If n equals -1, what happens?
In first formula.
In the first formula, when we have n equals -1.
In denominator we have 0 and we could not divide.
No,
any
this
number
formula
by
does
0.
not work. Look up. Let's agree that when n equals -1, this formula does not work.
Yes.
But what will be integral in this case when n equals -1? When n equals -1, we have formula number 3. Look, when n equals -1, it means x to power -1.
Mhm.
But x to power -1, it's 1 over x. And why this integral is equal ln x? Because I hope you remember derivative of ln x, it's 1 over x.
Mhm.
Okay. Next formula, it's k is constant, and constant we can move out of integral sign. The same properties we have in case of derivatives. Constant we can move out across derivative sign. And the last formula, this formula shows that integral of sum of function is sum of integrals. Unfortunately, we have no formula for integral of product of function. And that's why we have to use different techniques to find integrals when we have product of function or when we have quotient of function. Got it? Can I move to next slide?
I have a question.
Okay.
In fifth formula, in the left side there is plus minus, and in right side we have only plus, and this is
Yes, it's just technical mistake.
Taylor or okay.
Yes, it's just technical mistake. When here we have minus, when we have minus, here we have minus as well. And when here we have plus,
It's clear.
Here we have plus. Okay, now I now strongly recommend to write down these formulas or at least to take photo, because we need now to use these formulas to solve different problems.
But sir, there is in the last formula, the number 5 formula.
Okay, I missed here minus.
Is it not plus
Raymond,
or minus?
Here should be minus. So when we have plus, here is plus. When we have minus, here we have minus as well.
Yeah, that's what I'm saying. Is it not plus or minus?
Yes, he said it's a technical mistake.
No, there is something like plus or minus.
I included two formula in one, 2 in 1.
Okay, sir.
In fact, here 2 formulas. When we have plus fx plus gx, and when we have fx minus gx. 2 in 1.
Okay, sir.
Okay, now let's go back and find these integrals using this formula.
X to power 3 divided by 2.
Let's check, Sandro.
Divided.
I think I got the same thing.
Okay, what is next? What is next answer?
X to power 5 divided by 5.
Okay, very good. Okay, what do you think about first one? No, first, let's now first answer second question. Not first, but second question. integral dx. It means that here,
Integral of x plus
yeah, we
c.
have 1. Yes, it's
Yeah.
1. Very good. And what will be here in the first?
1 over.
No, Sandro, 1 is here.
The first, it's just constant number, and second x plus constant.
Yes, second is x plus c, x plus constant.
Yes.
What about first one?
C, only C.
Do you agree, Sandro?
It will be x to power 445 divided by 445 plus c.
Yes, I think something like that.
What do you think if we will move out 444, each constant number,
Oh.
and try to move out across integral side?
Uh, for-
X is 44.
X over 444 plus c.
Yes, because when we will move out 444,
Yes.
there will be integral dx. And you got it absolutely right, this integral, it's x plus c. What is next?
Wow.
X to power 4 divided by 4 plus c.
And last, and we need just to add -3 plus 1. Any questions, Raymond?
No questions. I'm just trying to do it myself.
Emmanuel, any questions?
No question.
But we would like to write it down. Sir.
Oh, very good, very
Yeah,
good.
but you send us this to our email, right?
Yes, sure. I will upload and you will be able to see this video. Also, I will upload this, all materials I will upload.
Okay, thank you.
Wow.
So this formula, first one, it works for any n. In this case, n equals 2 over 3.
Yes.
Any questions?
No.
What do you think? What is this integral?
X minus 2 minus square divided by minus 2 plus c.
Wow.
Oh my god.
0.
Do you remember we told that this formula, Luca, it works
It's
for any n,
undefined.
for all n,
We need
except
second formula.
n equals -1.
Not second.
So
Yes.
what is this integral?
It will be ln
ln x, absolutely. Any questions about it?
No.
Yes, sir.
Okay. What is your question, Raymond?
Recall property number 3.
Hashtag.
Number 3?
Yeah, number 3. Recall property.
This one?
No, the recall property.
Up. The answer.
The answer, sir.
This is the third formula.
Ah, okay. That's the formula we use?
Yes, yes, yes.
Oh, okay.
Integral of e to power x. It's e to power x again.
No, I understand that. Not that, sir.
Okay, very good, very good.
I'm, could get you. When the fx given that, dy dx is
Yes, it's dy divided by dx. It's derivative.
it was differentiation.
It's derivative.
Yeah.
And integral of derivative. Integral of derivative.
Integral of dy dx.
It's this function again. So to find y from here, to find y, it means to find integral for this function.
Yeah.
Because what we have here, what is written here? Here is written that derivative of function y equals this expression. And how to find y? To find phi, we need to find indefinite integral. And we did it.
So sorry, 1 minute. Derivative of x is 4ex, right?
Derivative of, not x, but derivative of e to power x.
Okay.
E to power x, look. E to power x, derivative of e to power x, it's again e to power x.
Okay, just.
Yes. Okay. So we finished today.
Okay.
And I will upload all materials and as well as video for this lecture, and previous lecture will be available. Okay, thanks for joining.
Sorry, hello. Sorry, sir. Where did you want to upload it?
On Facebook.
So we need
No, not on Facebook. I can upload on the Facebook group also, but it will be uploaded on the web page of our university.
Okay.
In our web page? No, it's very difficult. Sorry, sir, because in our page in the university is only writing Georgia.
Yeah.
Okay, I will upload on Facebook. I will upload on Facebook as well.
Exactly. So
Yes,
give us your Facebook so we can be.
Okay, it's okay.
Allah, good job, Imana.
Thank you, bye. See you soon.
Bye, sir. Yeah.
Thank you. Bye.
Yeah, look out.